Yes, I'm audible. Hello. It's okay. So in the last lecture, we have finished this capacitance. We have finished. So as I told that from the next lecture onwards, for the first 30 minutes, we'll be doing some good numericals, some tough numericals, and then we will start the normal chapter number 3. Yeah? This is how we will proceed now. So in the first 30 minutes, we'll be doing some good numericals, and then we will continue with the usual topics, the chapter number 3. So these numericals will be helpful if you are preparing for JEE or NEET exams. And if you don't have any plan for JEE and NEET, then this is also helpful for your usual numerical solving skills. It will improve your numerical solving skills. So we'll be starting from the first chapter onwards, electric field, like electros Coulomb's law. So these are some previous year's questions of NEET. Just give me 1 second. We'll start. So we will start with this chapter. Let's start with the first question. So that's the first question. Just no need to write the question. I will share this sheet with you. Okay, so can you tell me which formula, which concept we'll use here, Hishma? Yes, Hishma, which concept we'll use here? Huh? Just read the question. Coulomb's law. Huh? So the question says, this is the relation that we will be using. It's F is equal to K, Q1, Q2 divided by R square. So you have two charges, a charge is plus Q and another charge is minus Q. So this is Q and this is minus Q. They are placed at a certain distance apart. They are placed at a distance d apart. And force acting between them is F. So you can say that force between the charges is, it's K, it's Q divided by d square. So when we calculate magnitude, no need to write this negative sign. It does not matter whether you put this negative sign or not. That's my first equation. Then he says that if 25% charge of A is transferred to B. So if this is A and this is B, if I transfer 25% charge from A, Anshika, then how much charge will be left on A?
That's 75.
And how much will that 75 be? If the charge on A is Q, if I transfer some 25% charge from here, then how much charge will be left on A? So, Saifullah, if I transfer some Q by 4 charge, 25% charge means Q by 4 charge from this A, then how much charge will remain on A?
Maybe 100 minus 25.
So it will be 75% means 3 Q by 4. 25% means Q by 4, na? You are transferring Q by 4 charge, so the charge remain will be Q minus Q by 4. 25% can be written as Q by 4. And you are transferring this charge to B, so that will be minus Q plus Q by 4. So Q minus Q by 4 will be 3Q by 4. Minus Q plus Q by 4 will be minus 3Q by 4. Is it clear, Minashi? Noah?
Yes, sir.
And they are placed at the same separation. Now let's calculate the force again. So force is K. So this is 3Q by 4, Q1. Q2 is 3Q by 4 divided by d square. So force will be, it's 9 by 16. It's KQ square over d square. And what is KQ square over d square? That's F. So you can write this as, this is 9 by 16F. See, this KQ square by d square is F. So 9 by 16F means option. Is it clear? Hishma, Minashi, Arpit?
Yes, sir.
Yes, sir.
Okay. No need to write the question, huh? Just write the answer. Note down the solution. But please don't copy the solution, okay? See, these need previous questions are important for your board exams also. In boards, the tricky questions are usually from need previous years questions. If you go through the last year class 12 boards paper, first term, which was objective, then that paper have majority of questions which were from the need previous years. Just tell me if you have written. We'll come to the next question. Tell me once you have written, I'll scroll it down. See the next question. Do one thing. Okay, note down the question. Just note down the question and tell me which concept you will be using here. Note down the question and tell me which concept you will be using here. Noha, Uneeb, Yashika, written the question? Uneeb, written?
Yes, sir, writing.
Writing. Ishma,
Writing.
while writing question, try to decide which concept you will be using here and what are the given quantities. Try to make a rough sketch of the given data and the rest I will do. Decide concept, given data, write down the given data and then try to make a rough sketch of it. Written? Yashika, Saifullah,
No one is.
Arpit, you were not in the last class?
So actually, I'm not at my home right now. Sir, my grandparents are not well. And sir, I am wholly dependent on hotspots, sir, and they are not.
Okay, okay. So network issues, huh?
Yes.
You went through the recording of the last lecture?
No, sir, not yet. They were not, I guess, uploaded. So, sir, I didn't get the link.
Written now?
Yes, sir.
Okay. So see, the question says you have two identical charge spheres suspended from a common point by two massless string of length L. So you take two strings and you suspended two charges from this. Identical charges are there. So these two charges will repel each other. This is charge A and this is charge B. So you have two massless string, and from these two massless string you have two charges which are suspended. So charge A will repel this charge Q and this will move in this direction. So the force acting over this charge will be force, electric force. Mass is M. Is there any other force which is acting over this charge at B?
Attention.
Tension, yes. See, it's connected by a string, so there would be a tension. Any other force which is acting over this
Mg.
mass? Mg.
Mass.
Mass. So weight acting in the downwards direction. So these are the three forces, and this angle must be theta. So these are the three forces which are acting over this mass. And the system is in equilibrium. System is in equilibrium means sum of all forces will be zero. So in these type of questions, what we do is we try to resolve the forces along x and y axis. Electric force is already along x axis. Mg is already along y axis, but this tension need to resolve. We take one component of tension t cos theta, another component of tension to the left, which is t sin theta. Hishma, if the system is in equilibrium, can you tell me which two forces will balance each other?
Sir, what is Ng?
Weight.
No.
Weight
M.
of the charged particle. Yes.
Sir, I thought it's Mg.
No, no. Hishma, which two forces will balance each other if the system is in equilibrium? Oh, Minashi, which forces will balance each other if the system is in equilibrium?
T cos theta and Mg.
See, if the system is in equilibrium, that simply means net force is zero. So net force is zero only if this force acting in the upwards direction can balance this force acting in the downwards direction. If this t cos theta can balance this mg, then the system is in equilibrium. T cos theta will balance this mg. That's first equation. Yes, Ishma. Now, can you tell me which two more forces will balance each other?
T sin theta and FP.
Yes. T sin theta and electric force will balance each other. See, Uni, it's already written that they are initially at a distance d. So if charges are initially at a distance d, this is possible only if they are at rest.
Okay.
So if I take ratio, if I take 2 by 1, then I can write t sin theta over t cos theta will be equal to the electric force divided by the weight. T and T will cancel out. Sin theta by cos theta will be tan theta, which is Fe by Fg. How much is Fe? See, if this separation between the charges is D, separation between both the charges is D, then how much is Fe? We'll tell. Miraj, how much is Fe? The separation between the charges is D, one is Q, another is Q. How much is electric force? Miraj?
1 by 4 by epsilon naught. So 9 to
Over 4 pi epsilon naught. It's Q square over D square into mg. That is first equation. Third equation. Now, this is the equation when the system is in equilibrium. Instead of 1 over 4 pi epsilon naught, I'm writing just K. Now, the question says that charge starts to leak from both the spheres. The charge is leaking. So, Saifullah, if charge leak from both the spheres, then what will happen to their mutual force of repulsion? The force will remain same, it will increase, it will decrease. What will happen?
decrease.
It will decrease. So slowly, these charges will approach each other. If the charge starts to leak, then slowly these charges will approach each other. They will be moving in this direction. See, after some time t, the separation have changed. Now say this is charge q, this is another charge q. Separation is theta, but now separation have changed. Separation is not x, let's say d, separation is, let's say, 2x now, x and x. Now, and the charge is same. It's leaking, so the charge is q and q separation is x now. Now, now he's saying if charge leak means if q decreases, how that decrease in q will affect this x. See, the velocity with which charge move is nothing but dx over dt. So when the charge leak, these two charges will move towards each other. They will move towards each other with certain velocity. You're supposed to calculate that velocity. To calculate that velocity, what we can do is, this length is L. We can calculate tan theta from here, or we can calculate sine theta from here. Sine theta is the ratio of perpendicular and hypotenuse. Sine theta is the ratio of x and L. If angles are small, then sine theta are almost equal to tan theta. This is equation number 4. Tan theta we have calculated from third, means using the forces. Then we calculate tan theta through simple geometry. Now we can equate 3 and 4. So when we equate 3 and 4, we get x by L is equal to k q square over d square mg. So you get that q square is directly proportional to x. You just have to calculate the proportionality. It's not asking about the exact expression. So you can say that x is proportional to q square. Then how much is velocity? Velocity is dx over dt. Which is proportional to its 2q dq over dt. If you differentiate this 2q, then that will be 2q over dt. Now, seeing that charge from both the sphere leak at a constant rate. Which means this dq over dt is a constant term. This is k. So you can write that v is proportional to 2q into k now. But see, if
Sir,
you, yes.
sir, I didn't understand. So why did we equate um, equation 3 and 4?
Equation 3 and 4. See, in equation 3, we calculate tan theta. In equation
Yes,
4
sir.
also, we calculate the tan theta, this term. But the difference is, earlier we calculated tan theta from the forces. Now we calculate tan theta using the distances. I have to relate this x and q. That's the motive, to relate x and q.
Okay, sir.
Next, what we can do is, we have v is proportional to 2q into k. But if you look at our options, options are not in terms of q, options are in terms of x. So if you look at this equation, q square is proportional to x, which means q is proportional to x to the power half. So instead of q, I can substitute x to the power half. So that means v is proportional to 2x to the power half into k. Constants have no importance. Proportionality is given. xv is proportional to x to the power half. So the correct option is v is proportional to x to the power half. That's the option number 8. Note it down. See, the concept that we are using in this numerical is, as the charges leak from both the spheres, the electric forces becomes weak, and these charges will slowly approach each other.
Just scroll. Just scroll.
Okay.
Excuse me, sir.
Yes.
So how it become x to the power 1 by 2? Can you explain that?
See this one.
Yes, sir. Yes.
See, q square is proportional to x. Now, if you remove square here, take roots on both the sides.
Okay, okay, so got it. Got it.
Just scroll.
It's okay. Okay, just one more question from the Coulomb's law. Now let's make it a bit tougher. Next question. Let's increase the standard of the next question. Just 1 minute. After this question, we'll start chapter number 3. So we'll be doing both the things parallel, chapter number 3 and the revision of chapter number 1 and chapter number 2, so that you don't forget it. Revision means numericals, some really tough numericals. Like this numerical, this one. Note down the question. Make a rough sketch at least. Tell me once you have written the question. Start the solution. Noted.
So just a minute. Yes, sir, done.
Okay. Minashi, Saifullah.
Yes, sir, done.
Okay. Now let's start with the question. You have three charges Q, Q and minus Q. They are placed respectively at distance d by 2 and d from the origin on the x-axis. If the net force experienced by plus Q at x equal to 0 is 0, the value of small q is. So you have two charges plus Q. This is x equal to 0. On x equal to 0, you have a charge plus Q. Then this is Q. How much is this separation, Minashi? Just read the question. How much separation is this?
D by 2.
D by 2. Then at another d by 2 separation, you have another charge plus Q. So the net force at experienced by charge at Q is 0. You need this value of small q. Let's name this point as A. Let's name this point as B. Let's name this point as C. So this point A will experience two forces due to charge at A, B and due to charge at C. So charge at B will exert some force over it. The name of the force is FAB. Charge at C will also exert some force over it. Let's say the name of the force will be FC. Okay, just tell me one thing, Yashika. This charge Q should be a positive charge or it should be a negative charge?
So negative.
It should be negative. Hishma, can you decide why this Q should be negative? Hishma, can you decide why this Q should be a negative charge, not a positive one? Anshika? Anshika, why this Q,
Yes, sir.
why this Q should be a positive charge, not a negative one?
So because जो direction होगी charge को plus to negative.
Yeah, because the net force on capital Q could be 0 only if both the forces are acting in opposite directions. Then only forces will cancel each other. See, if one is repelling, then another should be attracting, then only they will cancel each other now. So it should be a negative. That will come through calculation also. Now we know that net force on this is 0. That means FAB plus FAC should be equal to 0. Hishma, how much is FAB? Just tell me how much is the force on A due to B. Just simple coulombs now I'm asking.
K plus Q by D by 2 square.
Yeah, so that would be D square by 4, right? And how much this FAC will be? Anshika, how much this FAC will be?
So KQ capital Q by D square by 4.
D square by 4. Right, Alia. R will be D. Huh? Just take it to the right hand side. So it will be KQQ over D square by 4, which is minus of KQ square by D square. This will cancel this term. Capital Q will cancel the square, K will cancel this K, and you will get Q, will be equal to minus of q by 4. This 4 will come to numerator, na? Then it get divided. Q will be minus.
How is it d square?
This
In
is this is d by
this
2.
case,
This is d by 2. This whole separation will be d. Right, Maraj?
yes. Oh, okay, sir.
Note it down. See, the motive of doing this subject is to learn numerical solving. That's it. Physics is not about just memorizing derivations and formulas. It's about numerical solving skills. You can score full in boards exams if you are good at numerical solving skills. And this half an hour, 40-minute session will help you in developing in that skills. So that was about Coulomb's law. These are the questions that are usually asked in Coulomb's law. In the next class, means on next Monday, when we will do this thing again, we will start with electric field. Electric field due to a point charge and a system of charges. Written, everyone? Alia? Ishma?
No, sir.
So done.
Okay. Next. Okay, so that was about Coulomb's law. In the next class, we'll start with the questions on electric field. So we are starting chapter number 3, current electricity. Now, this is easier than chapter number 1 and chapter number 2. Okay, Alia. So this current electricity, that's lecture 1. Electric current. So this chapter is easier than your chapter number 1 and chapter number 2. As we move forward, the toughness will decrease. Chapters are easier when you move forward. So this starts with the concept of electric current. See, what is electric current? Electric current is nothing but rate of flow of charge. A rate of flow of charge. Which means if you have a charge, that charge is at rest, then this is only a charge. This is a source of electric field only. Electric field or electric potential only. But if this charge starts moving with a certain velocity, then along with the electric field and magnetic field, there is one more phenomena that comes into existence. There is one more property that comes into existence, and that is current. Current is nothing but the flow of charge. If your charge is at rest, then it's only charge. It will generate electric field, it will generate electric force, it can generate electric potential energy. But if the same charge starts moving, then it's the source of current. Then this moving charge will generate current. So current is nothing but the flow of charge. So to calculate or to write the formula of current, what we do is we take a conductor. To write the formula of current, what we do is we take a conductor. Let's say the area of the cross section of conductor is A. Some charge delta Q enters the conductor and the time taken by the charge is delta T now. So I can write that delta Q is charge crossing the cross section of conductor in time delta T. So the charge crossing this area of cross section A in time delta T is delta Q. So you can write that current, the definition of electric current, I is its charge divided by time. This is the expression of current. See, whenever we use delta in the equation, this delta would mean that your current is an average current, that this is an average current when we use delta. But if I write this expression in this form, if I write I is dq over dt, like if I differentiate current with respect to time, that means your current is an instantaneous current. Your current is an instantaneous current. Next is current is not a vector, current is a scalar. Exactly, it's a tensor quantity, but we don't introduce tensor at school level. So we write current as a scalar. It's not a vector. Although current have direction, but it's not a vector quantity. It does not follow vector laws. Its SI unit is ampere. Although current have a direction, the direction of current is same as that of motion of positive charge. Direction of current is same as that of motion of positive charge. So this is the direction of current. Its direction is exactly same as that of motion of positive charge. That's the direction of current. So if you have a positive charge, this charge is in motion in this direction. This will be the direction of current. But if you have a negative charge, then the direction of current is opposite to its motion. Opposite to motion of negative charge. So the direction of current is exactly opposite to that of motion of negative charge. So if you have a negative charge minus q, it's moving in this direction with a velocity v. That means current will flow in opposite direction. Direction of current is exactly opposite to that of motion of negative charge. So this is the basics of current. Now, if I plot q versus time graph, this is time and this is charge. Say the graph is a straight line. This angle is theta. If I ask you to calculate the slope of the graph, how to calculate the slope of the graph, Mehraj? What will be the slope of this graph?
The delta q by delta.
Slope is tan theta, na? Right, Mehraj? If this angle is theta, then slope is tan theta. And yes, you were right. Tan theta is perpendicular upon base. Perpendicular is charge, base is time. So this is equal to q by t. And what is q by t, Anshika? Anshika.
Yes, sir.
And how much is q by t?
Sir, I.
It's I, it's current. Slope is Q by T, which is equal to I. So instead of Q by T graph, if I asked you to plot I versus T graph, let's say this is I versus T graph. So what is current into time? Current into time, Bhishma. What is I into T?
Q.
Q. So if I have I versus T graph, then the area under this graph, this area, will give charge. So area under graph, area under I versus T graph is charge. So these are the basic terms about current. Current is rate of flow of charge. Direction of current is same as that of motion of opposite charge and opposite to that of motion of negative charge. Note it down. And tell me if you still have any doubts.
Just go.
Yes.
Sir, what is a tensor quantity?
I don't want to go into that discussion. See, the way you divide quantities into scalars and vectors, we have scalar quantities and we have vector quantities. Actually, all quantities are tensors.
All quantities are tensors. We have zero order tensor, which are known as scalars. We have first order tensors, which are known as vectors. Then we have higher order tensors, which are known as tensors only. So just like vectors, tensors follow different type of mathematics. They have different rules. Just like vectors have different rules, tensor quantities have different rules. But since this tensor is not a part of syllabus, so we won't be using it.
Okay, sir.
So always remember one small rule. If a quantity comes by the division on y and x axis, like current is division of charge and time, the ratio of quantities on y axis and x axis, then that quantity will be obtained through the slope. If you have a quantity which you obtain by the multiplication of y and x coordinate, then that quantity will be obtained by the area under the graph. That's a general rule in physics.
So you can scroll little up.
Up, okay. Yes, written. Can I scroll it?
Yes, sir.
No, sir. Yes, sir. Done.
Now let's solve the first question, very first question. The question says charge flowing through a conductor, flowing through a conductor is, this is the expression of charge flowing through a conductor. It's 3t square plus 2t plus 1. Calculate first part. Current in 0 to 2 seconds. Second, current at t equal to 2 seconds. So Alia, in the first part, current in 0 to 2 seconds is an average current or instantaneous current? Okay. Anshika, 0 to 2 seconds is average or instantaneous?
Instantaneous.
Noha,
Sir, average.
Sir, average.
average. See, when you have time interval, instant is not given, it's 0 to 2 seconds. In between 0 to 2 seconds, a time interval is given. That means your current is average. Here, time instant is given at t equal to 2 seconds. This is the instant. This current will be instantaneous. Anyways, for the first case, which formula you will use, Alia? Which relation you will use? Huh?
Delta Q by delta T.
Delta Q by delta T. And what do you mean by delta Q? Delta Q means change in charge, final minus initial, by change in time T2 minus T1. See how much is T2? T2 is 2, T1 is 0. So it's 2 minus 0. How much is Q2? It's 3 into 2 square plus 2 into 2 plus 1 minus, if you put t equal to 0 here, it's 3 into 0 square plus 2 into 0 plus 1. This is Q2, Q1 and T2 and T1. So see, this is 4 into 3, 12, 12 plus 4, 16, 117 minus, this is 1 over 2. 16 by 2, so that is 8. Is it clear? Anshika? Miraj?
Yes, sir.
Yes, sir.
In the second part, you're supposed to calculate current at an instant. When you calculate current at an instant, it's derivative dq over dt. It's d over dt of q. How much is q? It's 3t square plus 2d plus 1. So when you differentiate it, you get it 6t plus 2. At what time you need this t equal to 2 seconds? So put t equal to 2 here. So you will get that your current is 6 into 2 plus 2, 12 plus 2, 14 ampere. Clear?
Yes, sir.
So this is how we differentiate between average and instantaneous current. Note it down, then we'll do the next question. And please don't copy numericals, huh? Just note down the question and do the solution on your own. Tell me once you have written. Can I scroll it further?
Yes, sir.
Okay, let's. See, it's just the derivative. So when you differentiate t square, the derivative of t square is when you differentiate 3t square, you can take this 3 outside and this derivative of t square only. Derivative of t square is it's 2t to the power 2 minus 1, which is 60. Okay, Alia? It's just derivative. The derivative of 1 is 0 and 2t is 2. After this question, there is one more question, and that question says, an electron revolve around the nucleus, revolve around the nucleus with frequency nu. Calculate current. So see, if I calculate current, the expression of current is charge upon time. How much is charge? Charge is E. And the time is the time taken by electron to complete one revolution around the nucleus. Does anyone remember what is 1 by T, 1 by time period? Frequency. 1 by time period is frequency. So your current will be E into frequency. So if the frequency of the charge particle is given, means the frequency with which the charge particle is revolving around the nucleus, then the charge multiplied by the frequency is current. Another question. If I give you current versus time graph, it's like this. I give you current versus time graph. This is 0. This is 10. Let's say this is 5. This is minus 5. And this is 10 seconds. Using this current versus time graph, calculate first part. Charge in 10 seconds. Second. Average current in 10 seconds. Alia, how will you calculate charge? Charge flowing through the system in 10 seconds if this graph is given.
So we will calculate the area of the graph.
Yes, to calculate current, we will use the area. So your current will be the area under the graph. How to calculate area? It will be area of this triangle plus area of this triangle. So the area of this triangle is positive and area of this triangle is negative. Just add them up. How to calculate the area of triangle? Mazia? No, not Mazia is not. This Noah. How to calculate area of this triangle?
Half breadth and
Half base into height. How much is base? Base is 5. How much is height? Height is 10. But if you look at this area is below the time axis. This is below the origin. So it should be negative. So it will be minus of half base. How much is this distance, Saifullah?
Yes.
How much is this distance here? 5 to 10. How much is this?
5.
5. And how much is this?
-5.
5. We take minus sign here, so don't repeat minus sign. So this will be 50 by 2, which is 25. This is 25 by 2, 12.5. So this is 12.5. This is current or charge? Area under the graph will give you charge.
This
That's
charge.
charge. Coulomb. Yashika, how will you calculate the average current? See, charge is known. Huh? How to calculate the average current? I need average current.
By delta D.
How much is delta Q?
So 12.5.
And how much is delta T?
10.
1.25 ampere. That's the current. 1.25. Clear? Okay, note down this from this question. Then we'll start the next topic. So these are the 3 types of questions that one can ask on current. The first one is on average and instantaneous current, second on frequency, third is on graph. Scroll. Written? Can I scroll it? See, the next topic is after current, the next is drift velocity. See, what is drift velocity? Drift velocity means velocity with which electrons drift towards the positive end of conductor under the action of external field. See, what happens is if you take a conductor, see, this is the initial condition. So I take a conductor without cell. I take a conductor and there is no cell connected with it. This is a conductor. A conductor have ions. So if I take a copper conductor, a copper wire, then this will have copper ions. Ions are immobile. Like they can't move from one end of conductor to the another end. And then we have free electrons. The electrons can move freely from one end of conductor to the another end. The electrons move some velocity, which is known as thermal velocity. See, due to temperature, electrons will have some energy, which is known as thermal energy. Due to this thermal energy, these electrons will randomly move from one end of conductor to the another end. It's U3, it's U4, it's U6. So due to the thermal energy, electrons are randomly moving from one end of conductor to the another end. And if I calculate the average thermal velocity, average thermal velocity of electrons, then that average thermal velocity V average is the sum of U1, U2 up to UN divided by N. Then that average thermal velocity will be 0. That's my first equation. This is the average thermal velocity. So average thermal velocity is 0. That means there is no net movement of electrons across the conductor. From here to here, there is no net movement of electrons. This means average thermal velocity of the electrons is 0. Now, if I apply some external field, this is the conductor. If I apply some external field means if I connect this to a cell, this is the EMF of the cell. If you apply a cell, that means this end will become positive, this end will become negative. So there is a field inside the conductor. The electric field inside the conductor, this is electric field. This electric field is due to this cell. Now, due to this field, what happens is ions are not affected by this field. Ions will remain at rest. There's no effect on these ions by the field. Ions will remain at rest. But these electrons, these free electrons, these electrons will experience a force. These electrons will experience a force in a direction opposite to that of field. Electrons will experience a force in a direction opposite to that of field. So electrons will move in a direction which is opposite to that of field. Electrons will move in this direction which is opposite to that of field. Due to this force, electrons will move from one end of the conductor to the another end. So along with these thermal velocities, due to this electric force, electrons will gain a velocity. This was when you did not apply any external source, any cell or battery. But when you apply a battery, then there is a field inside the conductor. This field will exert force on each and every electron. Due to this force, this electron will gain some velocity. And that average velocity of all electrons is known as drift velocity. Now to calculate that velocity, we will first calculate force on each electron. See, the force on each electron is EE. We can write that force on each electron is minus of EE. The direction of force is opposite to that of field. If I write that ME is mass of electron, then we can say that acceleration of electron will be acceleration of electron. What's the relation between force and acceleration, Alia?
Force equals to mx.
Force is equal to ma. So the acceleration is force divided by mass of electron. So force is minus of EE divided by the mass of electron. That is equation number 2. This is the acceleration. Now, if you have acceleration, you can calculate velocity also. Now, what happens is when this electric field apply force on this electron, then electron will move and collide with the ions. Then again, electron will move and then electron will collide with the ions. So the time interval for which electron gain velocity is the time taken by the electron between two collisions. Like if I show you two ions, this electron is here. Electric field will apply force on the electron. Electron will accelerate and then collide with the ions and then it stops. Electron then again accelerate and collide with the ion and then stop. So electron will accelerate for only that time interval, only that time which it take between two collision with the ions. So I write tau 1, tau 2, tau n time interval between collision of electron between two successive collision electron with ion. So you have time, you have acceleration, you have this initial velocity. We can calculate final velocity of electrons. Final velocity of electrons. So for the first electron, final velocity is this. V is U plus AT. It's U. How much is A? It's EE by M into tau 1. That's my third equation. What will be the equation for the velocity of next electron, Unib? This is for the first electron. Huh? Then what will be the velocity of the next electron?
Sir, U2 plus A plus tau.
Miraj, what is this tau exactly?
interval between two successive collisions, sir.
Collision of what?
Electron with ion, sir.
With ions. Very good. Similarly, we can write for n electrons, which is un plus a into tau n. So I can write this as this is un minus of E by m into tau n, that is fifth equation. So all electrons are moving with different velocities. But when you look at conductor, a current is flowing through a conductor, then you don't observe individual electrons. What you observe is the combined, the average velocity. So the average velocity of electrons, V average, is V1 plus V2 up to Vn divided by. Take individual velocities and then average. So, okay, just note it down, then we'll write it further. Just note it down up to here. Yes, Noha.
Scroll.
Is it clear up to this
Well
point?
done.
Minashi, any doubt?
No, sir.
Ishma?
No, sir.
So the next step, what we will do is we'll substitute these values. Let's call this as equation number 6. We'll substitute V1, V2, Vn from 3, 4, 5 here. So I will be substituting 3, 4, 5, and 6. When I make all these substitutions, what I get is I get that V average is V1. How much is V1? V1 is U1 minus EE by M tau 1. How much is V2, Anshika? V2.
U2 minus small e into capital E by M, and then that sign.
Okay, then we have UN minus EE by M into tau n divided by total n. Now see, what am I doing is I'm just taking these terms in a separate division. So I'm writing this U1, U2, UN by n separately. And from these terms, this term, this term, this term. Is there anything which is common here, Mehraj? Is there any term which is common in these three terms? Mehraj is not here. Noha, is there any common term in these last three terms?
So
M.
minus E by plus into
Minus E by M is common. So we have tau 1, tau 2, tau n divided by n. So how much is this first term? This first term is nothing but 0. Huh? And it's minus of EE by M into tau. So this is V average. It's minus of EE tau by M tau. That's the average velocity. And this average velocity is known as drift velocity. This average velocity. See, this is the average thermal velocity. Now we wrote in the first equation the average thermal velocity is 0. This average velocity is known as the drift velocity. This is what we call drift velocity. So the drift velocity Vd, if I just write the magnitude, then this is EE tau by M. This whole is known as relaxation time. So relaxation time is nothing but the average time taken by the electron to collide with the ion. Average time taken by electron to collide with the ion. This average time is known as relaxation time. And this negative sign shows the direction of drift velocity is opposite to that of electric field. Direction of drift velocity is opposite to electric field. So this is the average velocity which electrons drift towards the positive end of the conductor. Minashi, Saifullah, is it clear? Alia,
Yes, sir.
Arpit, any doubt?
Yes, sir.
Okay, note it down.
Scroll.
Scrolling. Okay.
Sir, why did we remove the negative sign in the last equation?
Just to show that I'm writing the magnitude. I'm just writing the magnitude, not the complete vector. Yes, written, everyone?
Yes, sir.
Okay. The next is the dependency on temperature. Like on increasing temperature, if you increase temperature, on increasing temperature, so when you increase temperature, then relaxation time decreases. The reason is when you increase temperature, you increase the thermal energy. Electrons will collide more frequently with the ions. So due to frequent collision, tau will decrease. And if tau decrease, then drift velocity will decrease. That's a very, very important one marker question. That what happened to the drift velocity if you increase the temperature? So when you increase temperature, then the frequency of collision will increase. Electrons will collide more frequently with the ions. And if the frequency decreases, relaxation time will decrease, drift velocity will decrease. No doubt. See, now the portion is very much theoretical. So we have 2, 3, 4 derivations, and after those 3, 4 derivations, we will do numerics. It's a long theoretical portion of current electricity. Current electricity is in 3 parts. The first part is theoretical portion, like how current flows due to the flow of electron. The second part is that of circuit. The third part is that of instruments. Instruments are related to your practical exams. Okay, so we'll stop here. I'm not starting the next topic today. In the next class, we will try to finish this theoretical topic. So this current is not a very lengthy chapter. It should not take more than 6, 7 lectures. So maybe in the first week of July, we can finish this current electricity. First or second week of July, I'll finish this current electricity. Okay, I'll stop here. Continue this in the next class. Okay, thank you. Bye.
Thank you, sir. Thank you, sir.
Thank you, sir.